This is Mrs. Rodriguez, and this is a recording for the Algebra 2 course. This is a review for the Chapter 4 test that's coming up. This is a practice test, selected problems from a practice test that can be found in your textbook on page 295. Okay, and just so you know, I just picked the problems that were most closely related to the test that you're going to take, and then I added a couple of extra ones that I felt would be very beneficial to you. They're very similar to the ones that are going to be on the exam, okay? And so what I recommend that you do as you're watching this video is as soon as you see a problem, pause the video, try it yourself, and then play the video again, and then check to see if your answer is the same as mine, and if it is, then move on to the next one, okay? All right, so let's go ahead and get started. Okay, so like I said, this is a video for Algebra 2 for the Chapter 4 test, and the practice test can be found on page 295 of your textbook. All right, so Chapter 4 is all about quadratic functions. So remember, when you have a quadratic function, you have something, it starts off with x squared. Okay, so when that happens, it creates this parabola, okay? All right, so you will be asked to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex, okay? So here's the first function. So first thing for the y-intercept is when x is equal to 0. So what you want to do is plug in 0 into the original function, and then use order operations to simplify. So you do exponents first, so 0 times 0 is just 0, and bring everything else down. Then you multiply. -2 times 0 is 0, and 5 times 0 is 0. 0 plus 0 is 0, okay? So the y-intercept is going to be equal to 0, okay? So we found the y-intercept, and then the equation of the axis of symmetry, okay, remember that is the x equals -b over 2a. So remember, this is your a value, this is your b value, and then c over here would be 0 because you're adding nothing, okay? So we have negative, and then b over 5 is 5, and then over 2 times -2. So this would be -5 over -4. So we have negative and negative, so that would be positive 5/4, okay? And then this is also going to be your x-coordinate of the vertex, okay, this here. So your x-coordinate is going to be 5/4, okay? So that's the equation. Here's the equation of the axis of symmetry, and then here's your x-coordinate over here, okay? All right. And then you'll also, with this same function, be asked to make a table of values that includes the vertex, okay? So when you have your, I'm going to create a table here. Okay. All right, so your the x-coordinate of the vertex we figured out was 5/4, so that's one of the values, right? So we want to go a few points before that, and then a few points after that to get an idea of what the parabola looks like. So I'm going to do 0, 1. I already know for 5/4. Oh, no, I don't know for 5/4. And then I have 2 and 3 I'm also going to use. So we already know 0 because we plugged in 0. This is the same function from the previous slide. So when x is equal to 0, we figured out that f of x was also equal to 0. So then I'm going to do for 1. So I've got -2 and then 1 in parentheses squared plus 5. Okay, so this is plus 5, and then, oops. Okay, and then this is plus 5. Okay, there we go. 5 times x, which we're saying is 1. Okay, so then this would be negative 2 times 1 plus 5 times 1, which is 2 plus 5. Oh, negative 2, sorry, negative 2 plus 5, which is equal to 3. Okay, and then for 5/4, and say negative 2 and then 5/4 squared plus 5 times 5/4 ends up being negative 2, and then times 5/4 is 25 over 16 plus 25 over 4. Okay, and this is negative 15 over 16 plus 25 over 4, which is 100 over, the 25 over 4 is equal to 100 over 16, which after you simplify everything is 3 1/8. Okay. Okay, sorry about that. This all got erased. Okay. Okay. So this, once you plug 1 in, this ends up being 3, and then the 5/4 ends up being 3 1/8. And then when you plug in 2, you end up getting negative 2 times 4 plus 5 times 2, which is negative 8 plus 10, which is positive 2. And then you plug in a 3, and for x, you end up getting negative 2 times 9 plus 5 times 3, which is negative 18 plus 15, which is negative 3. Okay, so then when you graph these points, you've got a point at 0, 0, and then you've got a point at 1, 3, so over 1, up 3, and then at 5/4, so a little bit more than 1, is 3 1/8, so that'd be like right here, and then at 2, it's going to be positive 2. Okay, and remember this is your vertex here. So this is the highest point of your parabola. Is opening downward because we've got this negative in front here. So, and then when x is 3, f of x is negative 3. So that'd be about here. And then this would be your parabola. Looks like that. Okay. And then, so we made the table of values, and it says to use this information to graph the function. Okay, which we just did. All right, so you're going to have a question about maximum and minimum values. So remember, if it opens upward, you have a minimum value, right? Because there's a lowest point, right? There's no highest point, there's no maximum because these arrows keep going upward. And then when you have negative parabola, remember it's flipped the other way, so it's opening downward. And then you're going to have a maximum value because your highest point, you can't go any higher than that. It just keeps going lower. Okay. All right. So if you got something like this, it says determine whether each function has a maximum or minimum value, and then state the maximum or minimum value of each function. Okay. So if we look at this Remember, there is a coefficient of 1 in front of x squared. If there's no coefficient in front of x, it's just 1. Okay, so, well, that's a positive 1, so we know this parabola is going to be open upward. So it's going to have a minimum value, okay? Minimum value. All right, and then to figure out the minimum value, we're going to use the axis of symmetry equation, the negative b over 2a. So that's going to be negative 10 over 2 times 1, which is negative 10 over 2, which is negative 5. Okay, so your minimum value is equal to negative 5. Okay, and then over here on number 5, same thing, but this time we have our coefficient is negative 1. Okay, so that means our parabola is going to be open downward, so we're going to have a maximum value. Okay, maximum value. So we're going to use the equation for axis of symmetry, and then that ends up being negative 6 over 2 times negative 1. So that would be negative 6 over negative 2. And we've got negative divided by negative, so that's positive. So that would be a positive 3. So the maximum value is positive 3. Okay. All right. And then you're being asked for solutions of a quadratic equation. So there'll be times where you have one solution. That means the parabola the vertex is right on the x-axis. A lot of times you'll have two real solutions where the parabola is crosses the x-axis at 2 different points. And then when you have no real solution, that's because the parabola is either above or below the x-axis, and it never actually crosses the x-axis. Okay. So it says solve each equation using the method of your choice and find exact solutions. Okay. So there's several ways that you learned how to solve a quadratic function. So our quadratic equation. For this one, I'm going to use factoring because remember, you need the multiples of, or the factors of negative 9 that add up to, in this case, negative 8. Okay, so you need the factors of C that add up to B. Okay, well, I know that negative 9 times 1 equals negative 9, and I also know that negative 9 plus positive 1 is negative 8. So since this one was easily factored, I would choose to use factoring, but it's up to you which method you want to use. Okay, so I've got x minus 9 and x plus 1. I set each of those equal to 0. And then I solve for x, and then x is equal to 9. And then over here, I would subtract 1, and x is equal to negative 1. So these are my two solutions. So if I were to graph this out, this parabola would cross the x-axis at positive 9 and negative 1. Okay. All right. And then for number 11, this is not so easily factorable. So I'm going to use the quadratic formula. And remember, that is negative b plus or minus the square root of b squared minus 4ac all over 2a. So remember, this is a, this is b, and this is c. So I end up with negative 40 plus or minus the square root of 40 squared minus 4 times negative 9 times 84. And then it's 2 over negative 9. And remember, you can definitely be using your calculator for this exam, okay? So we've got negative 40 plus or minus, and then 40 squared is going to be 1600 minus 4 times negative 756. And then 2 times negative 9 is going to be negative 18. And this is negative 40 plus or minus the square root of 1600 plus this here. This would be 4 times negative 756. And then after you add the opposite, it ends up being 3024. And then still divided by negative 18. And then you end up getting negative 40 plus or minus the square root of 4,624, still over negative 18. And then this is actually a perfect square, and you would probably not know that off the top of your head. So please, again, you can definitely use a calculator. The square root of 4,624 is 68 over negative 18. So when you do negative 40 plus 68 over negative 18, you end up with 28 over negative 18, which if you simplify is negative 14 over 9. And if you do negative 40 minus 68, remember you add the opposite, okay? This ends up being negative 108 and over negative 18, and negative divided by negative is positive, and it's actually exactly 6. So your two solutions are negative 14 over 9 and positive 6. Okay. All right, so question number 13 says, which equation below has roots at negative 6 and negative and 1/5, excuse me. Okay, so here, this is saying that when you set this x equal to 0, they end up getting negative 6 and 1/5. So you end up with x plus 6 and x minus 1/5. And this is equal to 0 because when you set x plus 6 equal to 0, you would subtract and you would get x equals negative 6, which is one of the roots. And when you set x minus 1/5 equal to 0, you would add 1/5 to both sides, and x would equal 1/5, which are these roots that it's asking about. So now what you're going to do is use the FOIL method to multiply this out, right? So this is x times x, so that is x squared, x times 1/5, which is positive 1/5 x. Oh, I'm sorry, this would be negative 1/5 x. Oh. No, it wasn't one. Okay. Okay, so I'll just, this is 1/5, okay? And then 6 times x is a positive 6x, and then 6 times negative 1/5 is going to be negative 6/5, okay? And then, so we end up with, when we combine these like terms, x squared plus, this ends up being, this is negative 1/5 plus 6, you end up with positive 29/5 x, and you still have that minus 6/5. And then when you're writing an equation, you cannot have fractions in your equation. So what you want to do is get rid of these denominators. So our denominator is 5. So you would multiply your equation by 5, and you end up getting 5x squared plus 29x minus 6. This is still equal to 0. And then, so that's going to be your equation here. 5x squared plus 29x minus 6, which was this one here, letter C. Okay. All right. So next problem. Oh, then there's a section that talks about imaginary numbers, okay? And the key thing here, remember that when you have a 1 squared, that ends up being negative, or I squared, excuse me, ends up being a -1. So here, you have a problem like this where you will have to distribute this negative. So this would end up being 3 minus 4i minus 9, and negative times negative is positive 5i. And then you just combine your like terms. So 3 minus 9, that's -6. And we still have the minus 4i plus 5i. So that ends up being -6 plus I. Okay? And that's as far as you can simplify. All right, and then number 17, here it says to simplify, so we cannot have this in the denominator, right? So we're actually going to multiply the numerator and the denominator by 4 plus I. Okay, and then we would distribute this 4i here, right? So this would be 16i plus 4 times I squared. And then down here, you would use your FOIL method. So you have 4 times 4 is 16. 4 times I would be positive 4i. And then negative I times 4 is negative 4i. And I times I would be, or negative I times positive I would be negative I squared. So we can, remember I squared is equal to -1. So this would be 16i plus 4 times -1. And then over here we have 16, and then 4i minus 4i, well, those drop out, and we still have this minus I squared, which is -1. So we've got 16i plus -4, and then we've got the 16 minus -1, you add the opposite, that ends up being 17. So it's 16i over 17 plus -4 over 17. Okay, and that is your final answer. You cannot simplify anymore. All right, so next section talks about completing the square. So remember, that's when you take half of b, okay, which is the coefficient of x, the number in front of x, and then you square the results, and then you add that to the x squared plus bx, okay? So here is just asking which value of c makes the trinomial x squared minus 12x plus b a perfect square trinomial. So remember, you would take half of b, which is, in this case, it's -12. So that's -6. And then you square it. Okay, so this squared is going to be positive 36, which is h. Okay, that's all it's asking you to do there. Here, this is an additional practice problem that I threw in there because you will have a question like this that'll say solve each equation by completing the square. So you will have to complete the square. So you take half, so this would be x squared minus 2x. You would subtract 8 from both sides. So this equals -8. So you end up with x squared minus 2x plus something, right, equals -8. And then you'd have to add it to the other side. So half of 2, or -2, is -1. And if you square it, well, that's +1. You have to add 1 to the other side of your equation as well. So when you factor this, it ends up being x minus 1 squared. And then this is -8 plus 1, which is -7. Okay, so then you have x, you would take the square root of both sides, and you have x minus 1 is equal to, now you can't take the square root of a negative number, right? But you have the imaginary numbers. So this ends up being I doing square root of positive 7, and then you're going to add 1 to both sides. So this ends up being x is equal to 1. And then when you're doing square root, this is going to be plus or minus I times the square root of 7. Okay? All right, so remember we had to have this imaginary number because the square root, you can't do the square root of a negative unless you're using imaginary numbers. Okay? All right, so then there's the quadratic formula. There's questions about the quadratic formula, right? So let's look at one. And there's also this discriminant. Remember, the discriminant is just what's under the radical symbol, okay? So we'll come back to this. It says, find the value of the discriminant. So remember, like I said, the discriminant is just what's under the radical symbol. So this is part A. So this would be b squared minus 4ac, okay? So first thing, I would rewrite this so that it's like in standard form. So I would add 6 to both sides. So this is 5x squared plus 6x. And then I would subtract 1. And then so now my equation is equal to 0. So now I see I have value of A, B, and C. So B is going to be 6 squared minus 4 times A, which is 5, and then C, which is negative 1. So this is 36 minus 4 times 5 is 20 times negative 1. So this is 36 minus negative 20. When you add the opposite, you get 56. So your discriminant is equal to 56. Okay, that's part A. Then part B says to describe the number and type of roots. Okay, so going back to this chart, this tells you how many, the type and number of roots. So if you have a perfect square, you're going to have, and if your discriminant is greater than 0 and it's a perfect square, you have 2 real rational roots. Okay, if your discriminant is greater than 0 and it's not a perfect square, you'll have 2 real irrational roots, because they're not perfect squares. When you try to find the square root, you end up with a decimal that just keeps going. So those are irrational, right? And if your discriminant ends up being 0, that means there's only 1 real root. And if your discriminant is less than 0, okay, remember that gets into those imaginary numbers, and then you end up with 2 complex roots, okay? All right, so this one here, our discriminant was greater than 0, but it is not a perfect square. So we were going to have 2 solutions because it is greater than 0, but it is not a perfect square, so that there are 2 irrational roots, okay? And then it says to part C to find the exact solution by using the quadratic formula. So remember that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then you just substitute everything. So this is negative 6 plus or minus 6 squared minus 4 times 5 times negative 1, square root of that, and then 2 times 5. So this ends up being negative 6 plus or minus the square root of 56 once you do all this, and then over 10. And then the square root of 56 has a perfect square, okay? So we could break that down because 4 times 14 is equal to 56, and this 4 is a perfect square. So when we simplify that, I'll put it over here, we end up with negative 6 plus or minus the square root of 4, which is 2, times the square root of 14, still over 10. So then we can simplify here, okay, because these have a common factor of 2. So this would be 5 2 goes into 10 5 times, 2 goes into negative 6 negative 3 times, and 2 goes into 2 once. So we can rewrite this as negative 3 plus or minus the square root of 14 over 5. So that is our final answer. So notice these are irrational, right? We would have to put this in a calculator, okay, to get a decimal approximation. All right, so next section talks about vertex form. And this is this formula here. So what you're going to do is you're going to be asked to write a quadratic function in vertex form, then identify the vertex, axis of symmetry, and direction of the opening. Okay, so first thing we want to do actually is identify the vertex and the axis of symmetry. Okay, so remember that's that x equals negative b over 2a. So for this one, we could rewrite this. We would subtract 2 from both sides. So we end up with 3x squared plus 6x minus 2 equals y. So this is a, b, and c. So negative b would be negative 6 over 2 times a, which is 3. So this is negative 6 over 6, which is negative 1. Okay, so that's the axis of symmetry. So the axis of symmetry is x equals negative 1. And then the vertex, we need that information. So we plug in the negative 1 into our equation here. So we have y equals 3, and then x is negative 1 squared plus 6 times negative 1 minus 2. So this ends up being 3 times 1 plus 6 times negative 1 minus 2. So this is 3 plus negative 6 minus 2. 3 plus negative 6 is going to be negative 3 minus 2. You add the opposite, and that's negative 5. Okay, so that means the vertex is at negative 1, negative 5. Okay, and remember, going back in vertex form, HK is the vertex. Okay, so this is H, and then this is K. So when we put this in vertex form, remember the vertex form is y equals a, and then x minus h squared plus k. Okay, so we needed to complete the square here first. So we could have taken out over here a factor of 3, and then we would end up with 3 times x squared plus 2x minus 2 equals y. And then we can leave it like that, right? Because we've got it in x minus h squared form. So this ends up being y equals a, which is 3. Okay, a over here is 3. And then we've got x squared plus 2x. Oh, when we factor this, that's what I forgot to. So this would be x plus 1 squared minus 2 equals y. Okay, so this ends up being x plus 1 squared, and then k, we figured out, was negative 5. Okay, so this is the equation or the function in vertex form. And then our vertex is here. And then the axis of symmetry is here. Direction of the opening, it's positive. So it would be, the parabola would be like this. So it would be opening upward. Okay. All right. So just to summarize, these are the different ways you should know how to solve quadratic equations for this exam by graphing. Okay. And it's going to be used sometimes only if it's an exact answer that's required. Okay, factoring is good sometimes when when you're looking at the function that you can easily identify the factors there. There's a square root property that works sometimes. Okay, when you have a perfect square is equal to the constant, and then completing the square always works. Useful for these types of equations. And then quadratic formula is best used when these are all too tedious, or you have something, you know, where your constant, your A, B, and C are a little bit more abnormal, right? Okay. So then this problem here, number 25, says to solve each inequality by using a graph or algebraically. All right, so here, what I would first do is set this, make this like in standard form. So I'm going to add 5 to both sides, and I get a x squared plus 6x plus 5 is greater than 0 or greater than y, right? Okay. So then I would rewrite this. This should actually be y. Okay. And I want my variable on the left side, so I'm going to rewrite that as y is less than x squared plus 6x plus 5. Okay. And then so my related equation would be y equals x squared plus 6x plus 5. So I see this in, I'm going to use factoring as my method for solving this equation, because I can see that this is a positive 5, and I know 5 times 1 is 5, and 5 plus 1 is 6. So this can easily be factored. So this would be x plus 5 and then x plus 1. So I set these equal to 0, and I've got x plus 5 equals 0. Subtract 5 from both sides, and x is equal to negative 5. And then x plus 1 is equal to 0. Subtract 1 from both sides, so x is equal to negative 1. So now I know that this graph, I have one of my roots is negative 5, so there'd be a point here, and then the other one is negative 1. So I know my parabola is going to cross the x-axis there, and then I also know that my y-intercept is positive 5 right here. Okay, so now I just need to know my vertex. Okay, so that's going to be x, that negative b over 2a. So this is going to be x equals negative 6 over 2 times a, which is 1. So this is negative 6 over 2, which is negative 3. And then I'm going to plug that in to the original equation to figure out my y value. So this would be negative 3 squared plus 6 times negative 3 plus 5. So this would be 9 plus negative 18 plus 5. So 9 plus negative 18, that's going to be negative 9 plus 5, and that's going to be negative 4. So the vertex is when x is negative 3 and y is negative 4. So that's negative 3, negative 4, okay? And then it's y is less than this, okay? So that means that my parabola should be dashed. If it was less than or equal to, then it would be solved. But it's only less than, so it cannot be equal to. Then what you have to decide is, am I supposed to shade, are the answers on the inside or the outside of this parabola? So you got to test a couple of values here. We can, oops, sorry. Okay, all right, so I'm going to test negative 3 and see if I'm supposed to shade inside of the parabola. So I'm going to put into my original inequality here, I'm going to put negative 3. squared plus 6 times negative 3, and see if that's greater than negative 5. So this would be 9 plus negative 18, and then 9 plus negative 18 is negative 9, and negative 9 is not greater than negative 5. This is false. So I wouldn't be shading inside. I would actually, the solutions are all on the outside of this parabola. So the way that I would write that is x can be less than, because it's everything less than negative 5. So when x is less than negative 5, or when x is greater than negative 1. So it's anything over here all the way around, right? Okay, so anything below negative 5 and anything above negative 1. So when x is greater than negative 1, okay? So nothing in between, okay? And that's how you would write your solution, okay? All right. And that's all that I have for you. So hopefully this video was helpful. If you still have questions, please feel free to call, text, email, or stop by my office hours, and I would be happy to answer your questions, okay? You have a great day.